Okay, let's just dive right into this explainer. We need to completely shatter this illusion that the code your AI built for you over the weekend is actually safe. We are going to look really closely at a massive blind spot in the modern development workflow.
You know the feeling, right? We've all felt that euphoria of vibe coding. You literally just describe what you want and bam! 48 hours later, tools like Cursor, Bolt, or Replit Agent hand you a fully working SaaS app with authentication and payment processing. But we've got to abruptly pivot to a pretty terrifying reality here, the invisible dangers hiding in that code. Because guys, functionality is absolutely not the same thing as security.
So, get this. The stark reality is honestly terrifying. A massive 62%. 62% of AI-attributed files on GitHub were found to be vulnerable. That's not just a little margin of error, right? That is a massive systemic risk sitting right smack in the middle of our repositories.
All right, Section 1, the vibe coding boom. Look, we are experiencing a massive generational shift in software development right now. AI is doing the heavy lifting, but we really have to understand what that actually means for our attack surface.
So here's the hidden danger. When we rely on these AI models that are trained on the public internet, they frequently just reproduce outdated patterns and known vulnerable code. I mean, they're learning from ancient Stack Overflow answers and vulnerable tutorials. And worse, they hallucinate. Your AI might confidently suggest installing some fake package, and a malicious actor can literally just register that package name and wait for your AI to download their malware. It's wild.
Moving on to Section 2, AI's fatal security flaw. Let's dig into how this vulnerability actually stems from a profound technological insight into how AI processes information.
So think about classic buffer overflows, where code and data get all mixed up in memory. AI is fundamentally vulnerable in the exact same way, because it treats your human instructions and completely untrusted data through the exact same neural pathway. With traditional SQL injection, you've got strict syntactic boundaries, right? But with prompt injection, you are dealing with semantic ambiguity. The AI simply cannot reliably tell the difference between a developer's command and an attacker's hidden instructions. And this means you don't even have to write the bad code yourself to get hacked. Your AI agent can read an infected GitHub issue, or process a poisoned README file, or even scan a malicious repository rule. And suddenly, it's hijacked without you ever even knowing. The attacker just hides the instructions right inside the data your AI is analyzing.
Now, as AI evolved from simple autocomplete to these Generation 3 agentic assistants, we got protocols like MCP, the Model Context Protocol. Think of MCP as basically the USB-C port for your AI. It seamlessly connects the AI to your local file system, your command line shell, your web browser, which is, incredibly powerful for development, but it massively expands the threat landscape. Looking at recent academic research, we can see exactly where these indirect prompt injections enter the tool runtime and manipulate the skill registry. An attacker places a payload in a file. Your agent reads that file through its new MCP connection, and boom, that payload tricks the agent into executing malicious tools directly on your local machine.
Okay, Section 3, Anatomy of AI Attacks. Let's dive deep into the rabbit hole and look at a real-world zero-click attack. Let's see exactly how these exploits escalate in the wild.
This step-by-step breakdown of the IDE Zaster exploit shows exactly how dangerous this gets. So, an attacker hides a payload in a GitHub issue. You completely innocently ask GitHub Copilot to analyze that issue. But the hidden payload tricks Copilot into quietly updating its own settings file to turn on auto-approve. And just like that, the AI has given itself permission to execute arbitrary commands on your machine, forever, without ever asking for your confirmation again. No way, right?
And this brings us to a really vital academic principle that proves why standard static filters are pretty much useless. It's called the attacker moves second principle. Because prompt injection operates in semantic space, an attacker can just dynamically change their wording, tweak their formatting, or use weird encoding to constantly bypass whatever static keyword filters defenders try to put in place.
The math on this proves standard filters simply aren't enough. When researchers tested adaptive attacks against state-of-the-art AI defenses, like PromptGuard or Model Armor, the attackers bypassed the security mechanisms over 78% of the time. And in some cases, they reached a 93% bypass rate. That is almost completely ineffective.
So make no mistake, this isn't just some minor bug that's going to get patched next Tuesday. It is a fundamental architectural crisis, and that's recognized by top cybersecurity authorities, including NIST, the National Institute of Standards and Technology.
All right, Section 4, the 4 defense layers. Since we know one wall won't work, we need a concrete blueprint for securing these rapid build applications using overlapping layers of defense. Because attackers so easily bypass single barriers, you absolutely must implement a 4-layer framework like the one outlined by Decode. Look, any vulnerabilities that slip past your initial configuration and AI prompts, they must get caught in human review. Anything that somehow passes review has got to get flagged in automated testing. And finally, governance ties the whole shebang together so you have an actual paper trail of exactly what your AI is doing at all times. Which brings us to Section 5, human-in-the-loop validation. This right here is exactly why AI cannot be left completely unsupervised.
As we move into review and testing, we absolutely need expert human oversight to catch the nuanced logic flaws that automated scanners just miss entirely. Methodologies from HackerOne show how human-in-the-loop validation creates these really powerful feedback loops. When human security experts validate AI code, they're actually training the AI at the same time. The AI develops system-specific memories, basically learning the weird quirks of your specific architecture, while also fine-tuning its generalized knowledge of broader security vulnerabilities. It's kind of like having your AI shadow a senior engineer.
But hey, we still need those automated safety nets, especially when it comes to secrets. Since AI tools frequently prioritize speed, they'll often just hard-code your API keys right into client-side JavaScript. Using tools like Core.js Secret Scanner is basically a non-negotiable step in your testing layer. And it doesn't just look for known. Actually, scratch that. It goes way beyond known patterns. It uses entropy analysis to find random strings and contextual AI to figure out if it's actually a real secret, which dramatically reduces those annoying false alarms.
Okay, Section 6, securing your vibe code. Let's wrap this up with some highly actionable steps that you can implement today to lock down your weekend projects before you push them to production. Before you ship, you need to actively audit the AI using the AI.
Sherlock Forensics recommends pasting 7 specific prompts into Cursor or Replit. Literally just tell your AI to run an authorization check, specifically looking for broken access controls. Tell it to verify all its dependencies, to make sure it didn't just hallucinate a package name. Ask it to check for missing security headers or verbose error handling that could basically hand attackers a roadmap straight to your database.
Ultimately, the crazy speed of vibe coding has to be balanced with just a brief, disciplined pause for security validation. Seriously, you spent 48 hours building the thing, just spend an hour actively forcing the AI to attack and audit its own work. Taking just 10 minutes per prompt could literally save your entire weekend project from a catastrophic data breach. So I want to leave you with this provocative thought to consider the next time you let an AI agent autonomously rewrite your entire repository. Your AI wrote the code in a weekend, but who is going to defend it when the attackers move second? These tools are incredibly powerful, no doubt about it, but the responsibility for the attack surface they create, that still rests squarely on your shoulders. Thanks for joining me on this explainer, and stay secure out there.